Alright, so in this problem, I have 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. So to solve this, I'm going to factor out 2 to the power of 10. So I get 2 to the power of 10 times 1 plus 1 is equal to 2 to the power of x. And 1 plus 1, that's equal to 2. So I get 2 to the power of 10 times 2 is equal to 2 to the power of x. And now if I divide both sides by 2, I get 2 to the power of 10 is equal to 2 to the power of x divided by 2. And 2 here, this is the same thing as 2 to the power of 1. If I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of 10, this is going to equal 2 to the power of x minus 1. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 10 is equal to x minus 1. Now if I add both sides, 1 on both sides, I get x is equal to 11. And now to check, my original equation was 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of x. X is 11, so I get 2 to the power of 10 plus 2 to the power of 10 is equal to 2 to the power of 11. And 2 to the power of 10 plus 2 to the power of 10, that is 2 to the power of 11. So this is right. Alright, so in this problem, I have 3 to the power of n minus 2 to the power of n is equal to 65. So to solve this, I'm going to first start by rewriting 3 to the power of n as 3 to the power of n to the power of 1. And I have minus 2 to the power of n to the power of 1 is equal to 65. And anything to the power of 1 is itself. So 3 to the power of n to the power of 1 is simply 3 to the power of n. Now, I'm going to rewrite 1 as 2 over 2. And 2 over 2, that's 1 again, so it's the same exact thing. And I'm going to do the same for 2 to the power of n. So now the reason I did that was because if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So n times 2 over 2, that's the same thing as 3 to the power of n over 2 times 2. Or sorry, to the power of 2. And the same thing for this. Now I'm going to let 3 to the power of n over 2 equal a, and 2 to the power of n over 2 equal b. So now I have a squared minus b squared is equal to 65. And a squared minus b squared, that's the same thing as a plus b times a minus b. And 65 I can rewrite as 13 times 5. So I have a plus b times a minus b is equal to 13 times 5. And we can say that a plus b is equal to 13 and a minus b is equal to 5. So now I have a system of equations. And to do this, I'm going to cancel these two out, add a and a, so I get 2a is equal to 13 plus 5, which is 18, meaning a equals 9. And if a equals 9, I can go ahead and plug in back to this one of these equations. I'm going to do here, so I get 9 minus b is equal to 5, meaning b is equal to 4. So a equals 9 and b equals 4. Now remember how we let a equal 3 to the power of n over 2. So 3 to the power of n over 2 equals 9, meaning n is equal to 4. And 2 to the power of n over 2 is equal to 4, meaning, again, n is equal to 4. So this is my solution. All right, so in this problem, I have x to the power of x to the power of 6 is equal to 144. So to solve this, I'm going to start by taking the power of 6 on both sides. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. And this is the same thing as a to the power of n times m. So x to the power of x to the power of 6 to the power of 6, I can actually switch these two places. So now I have x to the power of 6 to the power of x to the power of 6 is equal to 144 to the power of 6. Now I'm going to let x to the power of 6 equal to the variable y. And now, because we have 2x to the power of 6 over here, I can simply substitute in y for x to the power of 6 into my equation. So if I do that, I get y to the power of y is equal to 144 to the power of 6. Now what I'm going to do is rewrite 144 as 12 squared. So now I have y to the power of y is equal to 12 squared to the power of 6. So now what we're going to do is, remember how we have this property. If I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m, as well as a to the power of n times m. So I have 12 to the power of 2 to the power of 6, and this is the same thing as 12 to the power of 2 times 6. And 2 times 6, that's equal to 12. So I have y to the power of y is equal to 12 to the power of 12. And if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, y to the power of y is equal to 12 to the power of 12, meaning y is equal to 12. And now remember how we let x to the power of 6 equal to y. So I have x to the power of 6 is equal to 12, meaning x is equal to 6 root of 12. Alright, so in this problem, I have 3 to the power of x times 5 to the power of x squared is equal to 15. So to solve this, I'm going to first start by rewriting 15 as 3 times 5. So now I have 3 to the power of x times 5x squared, 5 to the power of x squared is equal to 3 times 5. Now, I'm going to divide both sides by 3 to the power of x, as well as 5. So then, for my left-hand side, both the 3 to the power of x's cancel out. For my right-hand side, both the 5's cancel out. So now I get 5 to the power of x squared over 5 is equal to 3 over 3 to the power of x. Now, if I have something in the form 1 over a, this is the same thing as a to the power of negative 1. So 5 to the power of x squared over 5, that's the same thing as 5 to the power of x squared times 5 to the power of negative 1. And now this is equal to 3 times 3 to the power of negative x. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So, in this case, I get 5 to the power of x squared minus 1. And now this is equal to 3 to the power of 1 minus x. Now, if I take the log on both sides, I get log 5 to the power of x squared minus 1 is equal to log 3 to the power of 1 minus x. And if I have something in the form log a to the power of b, I can move this exponent and b to the front, so it's going to equal b times log a. So in this case, I get x squared minus 1 times log 5 is equal to 1 minus x times log 3. And now I'm going to take base 5 on both sides of both logs, so these cancel out to get 1. So now I have x squared minus 1 is equal to 1 minus x times log base 5 of 3. And this means that x squared minus 1 plus x minus 1 times log base 5 of 3 is equal to 0. And this gets me to x minus 1 times x plus 1 plus log base 5 of 3 is equal to 0, meaning this is one equation, x minus 1 equals 0, meaning x is equal to 1, and if you solve this, you get x is equal to negative log base 5 of 15. Alright, so in this problem, I have a to the power of 3 plus a squared is equal to 80. So to solve this, I'm going to first start by subtracting 80 on both sides. So I get a to the power of 3 plus a squared minus 80 is equal to 0. Now I'm going to rewrite this as a to the power of 3 plus a squared minus 64 minus 16 is equal to 0. So I simply wrote negative 80 as negative 64 minus 16. And now, negative 64, I'm going to rewrite that as negative 4 to the power of 3. So I have a to the power of 3 minus 4 to the power of 3 plus a squared minus 16, I'm going to rewrite as 4 squared. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is going to equal a minus b times a squared plus ab plus b squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, if by using these two properties, I'm going to end up with a minus 4 times a squared plus 4a plus 16 plus a plus 4 is equal to 0. And this simplifies to a minus 4 times a squared plus 5a plus 20 is equal to 0. So now this gives me two equations. I get a minus 4 is equal to 0, and a squared plus 5a plus 20 is equal to 0. So for a minus 4 equals 0, a is obviously equal to 4. And for a squared plus 5a plus 20 equals 0, I'm going to use the quadratic formula, but I'm actually not going to waste your guys' time by actually doing it. So if you do end up doing it, you get that a is equal to negative 5 plus or minus the square root of 55i over 2. And the reason, actually what you should get is a equals negative 5 plus or minus the square root of negative 55 over 2. And the square root of negative 55, I can rewrite that as the square root of 55 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So if I replace I with the square root of negative 1, I get a is equal to negative 5 plus or minus the square root of 55 I over 2. So that's how I got square root of 55i. All right, so in this problem, we have the square root of 3 to the power of x is equal to 81. Now, to solve this, I'm going to start here with the square root of 3. So let's just ignore everything else for a second and focus on the square root of 3. Now, the square root of a number is, say, the square root of x. This is the same thing as x to the power of 1/2. Because basically, the root here is 2, but we just don't write that. And the cube root of a number, that's that number to the power of 1/3, because we have a 3 over here. So the square root of 3, we can think of 3 as x in this case, and we can rewrite this as 3 to the power of 1/2. So now, if I substitute in 3 to the power of 1/2 for square root of 3, I get 3 to the power of 1/2 to the power of x is equal to 81. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 1/2 to the power of x, that's going to equal 3 to the power of 1/2 times x, which is simply 1/2 x. And this is equal to 81. Now, 81, that's the same thing as 3 to the power of 4. So now I have 3 to the power of 1/2 x is equal to 3 to the power of 4, and this means 1/2 x is equal to 4, and x is equal to 8. So 8 is my answer.